So we'll continue with solving derivative problems. That is the second part. And in the last video, we stopped at the product rule. And then now we'll continue with another problem. This is like a quotient rule problem where y equals to 4 over x. And this is a quotient rule, that is a division rule. Find the y all over the x. So for this one, the solution, our dy over the x equals to, don't forget the formula, f of x derivative multiplied by g of x minus f of x multiplied by derivative of g of x all over g of x in square. So as always, first thing, we'll label this f of x, we'll label this g of x. So that is always the first thing to always do, label it. So our dy over the x will be equals to derivative of 4 is going to be 0 into bracket x minus f of x which is 4 multiplied by g, derivative of g of x, which is equals to 1. So derivative of x is 1 all over s square. So our dy over the x will be equals to minus 4 all over x square. And that's it. And this one too, we can use the we can try to simplify. Let's say we have another way to do this. Let's say we have y equals to 4 over x. This is the same thing as saying 4x raised to power minus 1. 4x raised to power minus 1. And then we can use the power rule, the power and the constant rule. So the y over the x in this case will be, don't forget, this is our a, this is our n. So a n x n minus 1. The y over the x will be equals to 4 bracket minus 1 x raised to power minus 1 minus 1 is equal to minus 4 x raised to power minus 2 over the x. So you can see it's the same thing, which we can also write as minus 4 all over x square over the x. This one too is the same thing as saying minus 4. This is the same as saying minus 4 x raised to power minus 2. So, and that's it. So the second one we want to do is the chain rule problem. Let's just label chain rule. Let's say y equals to 4x squared plus 6 all into square. So using chain rule, we can say let u equals to 4x squared plus 6, and therefore y will be equals to u square. Since this is u, then we can say y is equals to u square here. So solving it, we are going to have our dy over the x will be equals to derivation of this one. We can say it's going to be what? The u over the x multiplied by doing derivative of this, that is deriving and differentiating y with respect to u is going to be dy over the u, and then you can say dy over the x will be equals to du dx. This one, this is our du dx. If we differentiate that, we have 8x, and then multiply by dy du, which is this one, is going to be what? 2u. Dy over dx will be equals to 16x u. Don't forget what is our u. This is our u. This is our u. This is our u. you can say dy over dx equals to 16x into bracket 4x squared plus 6. So, and that's it. We can stop here. So another way to also solve it is also to say, let's say y equals to 4x squared plus 6 squared, right? So our dy over dx will be equals to, we'll differentiate this by bringing these two. We'll bring these two down, we have 2, and then we differentiate this as well into brackets 8x. Then we write this function again, or this function, which is going to be into bracket 4x squared plus 6, 2 minus 1. Then dy over dx, let me use this, is equals to 2 times 8x is going to be 16x. Bring this box again into bracket 4x squared plus 6. Can you see? Similar and straightforward. So most of the time, by the time we understand the concept, I will always use this one. I prefer to use this one at all times. And then the third one, we do the exponential rule function. Exponential. So we have where y equals to e 4x. Solution to this is our dy over du dx, equals to, we differentiate this first, which is going to give us 4, multiplied by the whole original function. You see, the whole of this function, which is going to be e4x. So dy over dx will be 4e4x, and that's it. So the fourth one, we'll still be working with the exponential rule, and then, but this case we have like a product rule kind of question. This is like a product rule. Find dy over dx. So the solution to this is going to be, we can label this as our f of x. Always label it. It makes it very easy. This as the g of x. See, combination of product rule and this. So what we'll do now is, you can then say dy over dx, which is equals to f of x derivative multiplied by plus f of x g differentiation of the g of x. So dy over dx will be equals to, differentiating this, x squared is going to give us 2x. G of x, we just bring the original function e3x, and then we do plus the f of x remain, which is still this. We have x squared, and then the derivative of the g of x, this, which we are differentiating this, we are going to have, we'll differentiate 3x first, which you can do as saying 3. If you differentiate 3x, you have 3, multiply by the original function e3x. So our dy over dx will be equals to 2x e3x plus x, no, we can just even say plus 3x squared e3x. So we can leave it like this, or we can over the s. We can take the like times. We have x e 3x as the like times in both equation. So we have x e raised power into bracket 2 plus 3x, and then so yeah. And another one, let's do the log problem, question 5, the logarithm problem. So we have y equals to the natural log x into bracket 1 minus x raised to the power of 8. So we want to do this. So again, this is a combination of product rule and the natural rule function. This is, let's say, this our f of x, this is our g of x. Very important to label. So solution dy over dx. Don't forget the formula, which is f of x, derivative of f of x multiplied by g of x minus f of x multiplied by the derivative of g of x all over, oh sorry, because this is a product rule, this is the product rule. So this is the formula of the product rule, that is plus, divided by this, I like this, divided by this. Only this is more like dividing it by the y function. So let's say y, let's say divided by y without the log, without the natural log there. So dy over dx be equals to the derivative of the f of x, which is x. Our f of x is x, differentiating it is 1 into bracket g of x 1 minus x raised to the power of 8 plus f of x, which is x, differentiation of g of x. This is like a chain rule in it. So we have, let's do this. This is like a chain rule. You can see this is like a chain rule. So we'll bring 8 down. 8 multiply by, we'll differentiate minus x, which is going to be of minus 1. And then the original 1 minus x raised to power 8 minus 1 all over. This is in addition with to like mixing the log function rule and the product rule, all over x into bracket 1 minus x raised to power 8. So you can come down to say dy over dx is equals to 1 minus x raised to power 8 minus, because this one is going to be minus x times 8 times minus 1 is going to be minus 8x to 1 minus x raised to power 7 all over x into bracket 1 minus x raised to the power of 8. Well, depending on how we can leave it like this, but we can still break this down as well. We can then see that dy over dx equals to, is the same thing as saying 1 minus 8 1 minus x raised to power 8 all over x into bracket 1 minus x raised to power 8 minus 8x into bracket 1 minus x raised to power 7 all over x bracket 1 minus x raised to power 8. As we can see, this we cancel this, this we cancel this, this we cancel this to be raised to power 1, 7 indices, guys. So we have dy over dx, which is equals to 1 over x minus 8 all over 1 minus x. We can also leave it like this, or we can still go further. Dy over dx equals to, we can take the LCM, minus x. This here is going to give us 1 minus x. This here is going to give us minus. This here is going to be x, so minus 8x. dy over dx equals to 1 minus 9x, that is minus x minus 8x over x into bracket 1 minus x. Yeah, we're good. We are good. Great. And that